So, I don't know if you can hear the Harley in the background. I have to get this done, so I'm going to have a Harley in the background. We are going on with trig equations. This particular topic is 4 examples long. I will need the unit circle for some questions. This depends on you knowing how to take care of the linear trig equations that was the note previous to this one. So you may need to go over that, or I may cover it well enough again in these questions that you won't have to backtrack. You will have to be the judge of that, and in addition to you being the judge of that, you also have to ask me tons and tons of questions if that is what is necessary for you to understand the material. So we're going to, I actually am lying to you, we're not going to solve quadratic trig equations, we're going to solve higher than linear trig equations. So I have 4 different examples. Some of them are quadratic, some of them are not. The first question is common factoring. So common factoring implies that you have something that is common, and I know that sounds pretty sarcastic, but I swear it's not. Oh, the Harley is leaving. Before we start, or somewhere along the line, you have to know what your answers are supposed to look like and how the space is. So, for instance, in this particular question, I'm using thetas instead of x's, and I'm being asked to answer between 0 and 2 pi, and that indicates that we are talking about radians. Now, you are totally allowed to think off the top that that is 0 to 360 degrees, because 0 to 2 pi radians is 1 rotation, and 0 to 360 degrees is 1 rotation. So they're the same thing. So all you need to do is pretend like it's in degrees all the way to the very end, and then at the very end you convert to radians. So that's a way that we can approach any question that is in radians. However, if you want to know how your calculator works in radians, then let me know and I will show you. So let's look at this first question. It is completely illegal to cross out a tan on both sides and then say either that cos squared theta is equal to 1, which it is, or to 0. This loses you information, so you have to keep it in there. So this little thought bubble off to the side says move all terms to the left side and factor out the common factor. So that implies there is a common factor. So I am going to take tan theta cos squared theta. I'm going to minus the tan theta from the right to the left equals 0. Now in a minute I'm going to put some stuff in here, but some of you might be able to see that there is a common tan theta between this term, which is term number 1, and this term, which is term number 2. When you common factor the tan theta, you're left with cos squared theta from the first term minus 1 as a placeholder for the second term equals 0. And some of you might recognize that cos squared theta minus 1 is a difference of squares. So we could take that down to cos theta. This is my brother texting me over and over and over. But your difference of squares, oh my gosh, it's 8 messages. I think he's done. So there's the difference of squares. So this is as factored as it can be. It requires you to know that first unit of factoring that we did way back in September. But if you don't notice that, I want to go over here to the side, and in blue I want to give you some information that you could put in between there to get yourself to there. So the first thing you could do, and this is a strategy, you could pick two letters. So I'm going to pick X and Y. I am allowed to pick X and Y because they aren't in here. I also like X and Y because they don't look like any of the numbers I would use. So I am going to designate that tan theta, every time I see tan theta, I'm going to replace it with an X. And every time I see cos theta, I'm going to replace it with a Y. So what that means is that either in the top line, I'm going to go to the second line, it means that I've got X for tan theta, cos squared, so that's Y squared, minus X for tan theta equals 0. And maybe you can factor this easier than you can with the trig. So I'm going to do that now. I'm going to common factor out an X, leaving behind Y squared minus 1 in the bracket. And then I notice that Y squared minus 1 is equal, or is a difference of squares. So I can do Y plus 1, Y minus 1, and then I can take it down and replace them back again. So the X was the tan theta, the Y was the cos theta in two spots. So now I can do the little green writing. So the green writing I'm going to do here is tan theta equals 0. That's this piece equals 0. Or cos theta plus 1 equals 0. That's this piece equaling 0. And cos theta minus 1 equals 0. So the things I have to solve, the pieces of information I have to get answers for theta for, are tan theta equals 0. That one was done. Cos theta is equal to negative 1. And cos theta is equal to positive 1. And whether you realize it or not, this is a unit circle measurement. This is a unit circle measurement. I can find cos theta is equal to 1 on the unit circle. I can find cos theta is equal to negative 1 on the unit circle. And I can also find tan theta is equal to 0 on the unit circle because tan theta is sine theta over cos theta. It means that cos could be anything as long as sine theta is 0 to make the fraction 0. So now I'm going to list the stuff, and I'm going to list it here, and I'm going to have to bop back and forth, so I do apologize for that. I'm going to give you a therefore statement, and I'm actually going to cut down on my work because these are on the unit circle, so I don't have to pluck off the answers in degrees. I can pluck off the answers in radians and save myself the conversion at the end. That's not okay when it's off the unit circle, but it's perfectly fine for the unit circle. So I'm going to go and I'm going to find all the places where sine ratio is equal to 0. So sine is the second one. So sine is the second one, is here and also here. So I'm going to have to write down the radians. So I'm going to write down 2 pi. I'm going to write down 0. That one's doubling up, which is why it was so important to have that on your resource sheet. And pi. So I'm going to list all three of those beside my therefore statement in whatever order I feel like doing. What is very important is that you specify that it's in radians. So I've got pi radians, 2 pi radians, and 0 pi radians. Now I have to go searching for all the places where cos theta, the first coordinate, is negative and add the numbers to my list. So cos theta is negative 1 is here. And because I've got pi on my list, I don't have to write it down again. And I also need cos theta is equal to 1 and it's here. So it's these two answers, which are already in my list, so I don't have to write it down again. And if you take a look at these answers, every single one of them is between 0 and 2 pi, and it's in radians, so I've covered what I'm supposed to here. And that is a common factoring question. It also kind of covers what we did yesterday, or sorry, last lesson. In these are just linear equations that need solving with trig in them. So let's move on to the second type of question. And the second type of question requires you to trinomial factor. It could require complex trinomial, like the answer here, or it could require simple trinomial. There's also the case of difference of squares, which is like a trinomial, only it's missing the middle term. So with this question, you can use the exact same strategy I used in question 1, and that is the replacement strategy if the factoring kind of bogs you down. So I am going to do both methods. I'm going to put a little wiggly line down here. I'll do the replacement method on the left and the other method on the right. So here is my wiggly line. Not sure how long I'm going to need it. So if you are completely freaked out by the fact that you've got trig and a trinomial all together, then you need to replace whatever word it is that's bothering you. So in this case, the only word in there is sine x. So I am going to let m equal sine x. I can't use x this time because x is in the question. So that turns it into 3m squared minus 1m minus 2 equals 0. And then I can take this, which is a complex trinomial from grade 9 or 10 or 11, and we can do our little scribbly method, which I'm going to do here. So two numbers that multiply to be 3, two numbers that multiply to be 2, crisscross, try to make the negative 1 in the center. So here's a bracket, and here's a bracket. So 3m plus 2, 1m minus 1 equals 0. And you've got no reason to turn this back into trig until after you figure out what the m's are. So 3m plus 2 equals 0. Might annoy some of you. M minus 1 is equal to 0. This one is 3m is equal to negative 2. So m is equal to negative 2/3. This one is m equals 1. So that's a quick one. So we end up having to get answers for, remember what we let m equal, sine x. Sine x is equal to negative 2/3. And then we also have to go searching for sine x is equal to 1. Now I'm going to drag this stuff to the center. And the reason I'm dragging it to the center is I can extend my little wiggly line, because if you didn't feel like doing the replacement method, then you're going to end up having to trinomial factor this, and you would end up with 3 sine x plus 2 times sine x minus 1 equals 0. So you would still factor this way, only instead of having m at the beginning of each bracket, you would have sine x at the beginning of each bracket. Green pen time. 3 sine x plus 2 equals 0. 3 sine x equals negative 2. Divide by 3, divide by 3, and you end up with sine x is equal to negative 2/3. The other bracket, sine x minus 1 is equal to 0, so that means sine x is equal to 1. So regardless of whether you use the replacement method or the I can see trinomials inside trig question method, you get these two answers. A textbook will likely not show you this method, mostly because it's a strategy, not a full-out method. Either way, you get these two blue statements, which are linear, and you have to decide if one or both of them are unit circle or one or both of them are cast rule. And fortunately, there's one of each, so I get to review both. So this is a cast rule question, because if I check the unit circle, I do not see negative 2/3 on it for sine. And this is a unit circle question, because this is on the unit circle under sine. Excuse me. So I'm going to do this one first, just because it's the most amount of work, and then I can take the therefore statement from this and just tack on the others that I can pluck off the unit circle for this. So back to the cast rule. Here's our cast rule. C-A-S-T. Cos is positive, sine is positive, tan is positive, all are positive. And we're looking for sine having a negative answer. So not here and not here, because that's where it's positive. So I'm going to put my little stick here, and I'm going to put my little stick here. Now I do my RAA business. So RAA equals sine inverse of, break for a cough. Wow, itchy throat. Didn't mean that. Sine inverse. And you have to remember from the last lesson that you don't put negatives into your calculator. Technically, all the negatives are telling you to do is where to put these red terminal arms. So I need to dig out my calculator. See if I can find it. And just like the last lesson, I have to make sure that my calculator's in degrees. And I have to type this in. Where'd it go? So 2 divided by 3 equals, there's that decimal, complete form, haven't rounded in any way. Trig, I need to do second function sine, and I get 41.8, and that is 41.8 degrees. Now at some point you need to remind yourself, and in this case me, what we're looking for. And we're looking for all answers in one rotation of the unit circle, but our answers have to be in radians. So this 41.8 is kind of incomplete. It's even incomplete if you figure out where it goes on the cast rule, and it's even incomplete when you pull off that this angle is 360 minus 41.8, and that this angle is 180 plus 41.8. I mean, that's just not good enough. We still have to figure it out, even if it's not good enough. So, x is it x? It is x in this question. So x equals, so first one, 180 plus 41.8 equals, and I get 221.8. Don't know why this keeps happening. 221.8, and that's 221.8 degrees. And then the other one, 360 minus 41.8, and you have to go back to the lesson before for the little graphic of why this is the way it is. That other one is 318.2. And both of these, while I'm here, we're going to have to times by pi over 180 to turn them into radians, so I get my real live therefore statement. So while this is on the calculator, times pi divided by 180, and that answer is 5.55. 5.55 ugly radians that you use the pi as a decimal so it doesn't slide in there. And then the first one was 221.8. 221.8 times pi divided by 180 equals, it's 3.87. Again, radians, no pi because we built it into our calculation. Now I am going to add on to that, and I am going to add on to that whatever answers I get here on one rotation of the unit circle where sine is equal to 1. So I have to find every place on the unit circle where sine, the second one, is equal to 1. And that's not it, that's -1. So it's here. And then once I find the 1, I can write down the degrees if I want to, but for sure the radians. And it's the radians for sure because that's what I was being asked for. So I can put that here, x equals pi over 2 radians, and add it in here. If you really want to turn that into a decimal, then you can do 3.14 divided by 2 or pi button divided by 2. But this, for my eyes, are prettier than these two guys. So I personally would leave unit circle ones pretty and take the ones where you have to round and round them to 2 decimal places. And that's usually my instruction, is to leave them to 2 decimal places. All right, next question. What could I possibly do to you? By the way, I don't do anything to you. It's the math. So do you see the problem here? The problem here is that we have 2 trig ratios, cos x and sin x, and no way to connect them except your identities. So we have to find a replacement for one or the other, and there is no replacement for sin x to turn it into cos x, but there is an identity for cos squared x to turn it into sin x. More specifically, 1 minus sine squared x, and you can check your Pythagorean identities to find that out. So I'm going to write all this down. So -10 bracket, and then in that bracket, instead of cos squared x, I can put in 1 minus sine squared x. Oh, I'm going to sneeze. I think I caught that in time. So that's the replacement there, minus 3 sine x plus 9 equals 0. We're going to have to multiply this bracket out. -10 plus 10 sine squared x minus 3 sine x plus 9 equals 0. 10 sine squared x minus 3 sine x, -10 plus 9 is -1 equals 0. And you can choose your strategy. You can complex trinomial factor this, or if you can't see it, you can do your replacement. I would advise against doing your replacement in any other position than this one. Maybe the one ahead of it, maybe this one, but definitely not here, because then you're never going to notice your identities. Before I go too far off the screen, this question again is asking for x's that are between 0 and 2 pi, so all the places on the unit circle, one rotation. Some of them pretty, possibly. Some of them ugly, possibly. Depends on what these brackets end up being. I am going to do the one strategy where I change these to m's. So I'm going to let every single sine x equal an m. So this turns out to be 10m squared minus 3m minus 1 equals 0. And then I'm going to complex trinomial factor that. It might be more obvious that it's a complex trinomial question here rather than in the black one where there's trig. So I need two numbers that multiply to be 10 that add to be 1. Yeah, that'll work. So 5 times 2 for 10. 1 times 1 for 1. 5 this way, 2 this way. Could you tell there was a panic in my voice there? I mean, if I couldn't factor this, what do I have to do? I would have to use the quadratic formula. So these questions can and might get pretty nasty. Let's see what I have after we're done this one. So I need -5 plus 2 to make -3 in the center. So that's negative on the bottom, positive on the top. My two brackets look like bracket 5m plus 1 and 2m minus 1 equals 0. Green pen. 5m plus 1 equals 0. So 5m is equal to -1. Divide by 5. Divide by 5. Remember, you could say m is equal to -1/5, or you can skip yourself a line and say sine x is equal to -1/5. Then I'm going to do the same thing with this one. 2m minus 1 equals 0. 2m equals 1. Divide by 2. Divide by 2. So sine x is equal to 1 over 2. And then you get to decide what is a unit circle measurement and what isn't, regardless of how you got this factored. I hope you know, especially if you've got a resource sheet, that this is a unit circle measurement because you can find all sorts of sine x ratios that are a half, but this one not so much. So this is a cast rule question, and I'm going to start there, mostly because it's on the left. So here's a picture. C-A-S-T, I need that. This is sine has a negative value, so it's positive here and here. So it's negative in the bottom two quadrants. And eventually I will find my RAA and put them in those two spots. So the RAA is sine, oh, here comes the Harley, inverse of not -1/5, of +1/5. The negative got used up by putting your sticks there. So 1 divided by 5 equals 0.2, not part of your answer. Trig, second function, sine, 11.5 degrees. And it's degrees. So in this spot, it's 180 plus the 11.5, because you're going from here to the 180 mark and then that little bit extra. And this one is 360 minus your 11.5, because we're going all the way, oh, not quite all the way around to 360. We've fallen short by this amount. So remember to look back to the previous note to find out what each quadrant is in relationship to its RAA. So my first level therefore statement is these x's once I calculate them. So 360 minus, oh, let's do 180 plus 11.5. 180 plus 11.5 is 191.5, and that's degrees. This one I'm not so good in my head with. So 360 minus 11.5 is 348.5 degrees. And if you leave those there and go on to this, that's fine, but you're not going to get full marks until you check to see if it's radians, and it is, so you have one last line. So I'm going to do my conversion before I dig out my unit circle. My choice. It doesn't really matter. So I'm going to take these guys, and individually I'm going to times them by pi over 180. I don't need to see that work. It needs to happen. So although I'm writing it there in red, you don't need to write it down. So 348.5 is still on the calculator, times pi divided by 180 is equal to 6.08, and that's 6.08 radians. You have to specify. And 191.5, 191.5 times pi divided by 180 equals 3.34 radians. So, this therefore statement, even though I've got a monstrous therefore, it's not done until you deal with the other half of the question. So this part right here. So I'm going to go to the unit circle and I'm going to find every spot on the unit circle where sine is equal to a half. Now sine is positive a half, so really the cast rule tells me I'm only looking in the place where sine is positive. So these upper two spots. Even if I looked in the lower, I'm not going to get answers. So I'm going to erase what I've got, and I'm looking for sine is equal to a half. Sine is the second one. So see, these second ones are all negative. These second ones are all negative. So I'm going to write down 30 and 150. Actually, I'm lying to you. I'm not writing down 30 and 150. I'm going to write down the radian measures to save myself some time and work. So pi over 6 and 5 pi over 6. Pi over 6 radians and 5 pi over 6 radians. And then I'm going to take those two answers and finish off my overall therefore statement. So you can tell in the therefore statement whether you had a unit circle question or whether you had a cast rule question or whether you had both. If you've got a unit circle question, all of these answers will have pi's in them. If you had a full-scale cast rule question, you would have all ugly decimals. If you have a little bit of both, you have a little bit of both. So I'm going to take a little break for my hand cramp and come back to you to do this question, which you should have predicted. I mean, really, come on. We're not going to avoid that thing. You got taught that in grade 10 for a purpose, and it's to do more and more and more math. What I'm doing here is I'm also including identities. So I will be back in a moment. Okay, my brother might text me again. Just so you know, I had no idea what he's talking about. It was like a letter every line. It was ridiculous. Anyhow, my hand cramp is gone. And here's a combo question. It's truly a combo question. And when you're talking about identities, the most famous identities to use are the Pythagorean identities. You have 9 of them, but I'll be honest with you, only 6 of them are really all that useful. And the reason is because 3 of them actually are equal to 1, and very rarely do you want to turn the number 1 into crazy trig. What you want to do is you want to turn crazy trig into other crazy trig. So with this particular question, we've got secant x that's squared and tan x. And there's no way to turn tan x into secant x, but there is a way to turn secant squared x into this word. Mostly because, and I don't know exactly which one's written on the sheet, but secant squared x is equal to tan x plus 1, or it's equal to 1 plus tan squared x. Whichever version you have, it's the same deal. I'm going to use this one, just for fun. So 1 plus tan squared x replaces the secant x. Unlike the last question, where I needed to insert it into a bracket because there was a number out front, This one has no number out front, so I don't need the bracket. I can keep writing, and I already know, based on the rest of this course, that I need a 0, so I might as well move that over. And then I can collect like terms. So tan squared x plus 5 tan x plus 3 is equal to 0. And if you can't see that this is a trinomial, simple trinomial, then go all m on it. Now the other option is nothing. Sorry, I had a little brain fart there. The other option is you just see it, I guess. So I'm going to use the m's. Sorry for that brain fart. I'm going to let tan x is equal to m, which means m squared plus 5m plus 3 is equal to 0. And maybe now you can notice that this is not factorable. You will be sitting there for the rest of your life trying to find two numbers that multiply to be 3 that make 5, because this is a simple trinomial. So it's time for the quadratic formula. So let's see if I don't screw this up. So negative b plus or minus root b squared minus 4ac all over 2a is not equal to x, it's equal to m, because you've already got x's up here. A is 1, b is 5, c is 3. Watch me very carefully, make sure I don't screw up. So b is 5, so that's negative 5 plus or minus 5 is b squared minus 4, a is 1, c is 3, all over 2, a is 1 again. Whew, I think I did that. So m equals negative 5 plus or minus something over 2. That something is under a root, so this is 25 minus 12, that's 13. And there's absolutely no point to you doing reduced radical form for this, so I'm going to go straight to finding decimals. So I will have m equals something and m equals something else. So let's move this over so I can see my work. I wish this calculator was a little bit smaller. So, reminder how to plug this in. Negative 5 plus 13 square rooted, or the other way around with your calculator, must hit equals to finish off the top, then divided by 2 equals. And I'm going to ask that because this is not your final answer for degrees or radians, you write this down to 4 decimal places. So negative 0.6972. Negative 0.6972. And I said that wrong because it's really negative 0.6972. You're not supposed to bulk numbers when you read decimals. The other one. Negative 5 minus the square root of 13 equals, to finish off the top, divided by 2 equals, and this is negative 4.3028. So why am I saying it like that? Well, I have to remember it, and remembering 3028 is easier for me than remembering 4 numbers. So that's why I'm bulking them. So back to the question. Oh my gosh, I've forgotten what word I replaced. I replaced the ratio tan x. So I have 2 questions. I have tan x is equal to negative 0.6972. And tan x is equal to negative 4.3028. And both of these are not pretty numbers, so they're both the cast rule. I recommend that even though both of them are negative, that you draw yourself a cast rule per question. So I'm going to do a cast rule here, and I'm going to draw another one eventually to fill in here. I'm not going to do it quite yet. I can only handle doing one thing at a time. So there we go. Tan is positive here and here, but I don't have a positive, I have a negative. So I'm going to put my sticks here and here. And then I'm going to RAA this. And I'm going to remember to not put in a negative. So 0.6972, second function, oh no, second function tan. So to one decimal place for degrees, that's 34.9. And remember, this is not your answer. This is your RAA. So we're going to need to figure out this rotation, which is 180 minus 34.9 degrees. And we're going to have to figure out this rotation, which is 360 minus 34.9 degrees. Now I'm going to show you a little trick with this question. It's a lazy trick. You may have figured it out already. It's not rocket science. I need my answer on one rotation, and it needs to be between 0 and 360, and it needs to be radians. So I'm figuring out all these degrees, and I need to actually convert them to radians. So my calculator's in a good spot. So 180 minus 34.9 equals that many degrees. I don't want to write that down. That's not an answer. Times pi divided by 180, I can write that down. 2.53 radians. Move on to the next one. 360 minus 34.9 is that many degrees, which I don't care about. So while it's on the calculator, times pi divided by 180 equals, and I get 5.67 radians. And then I'm going to go on to this. Now before I start all that work, I'm going to shift this over a teensy bit, and I'm going to shift over my calculator. So this time for my RAA, and all of this is review from the last lesson, so you're getting a 2-for-1 deal. RAA is equal to second function tan of 4.3028. And at some point, whether it's now or later, you should actually draw yourself a little cast rule so you can figure out where things are. So tan is positive there and there, negative in the same two spots, not coincidentally, as the last question. So now I know what the degrees will be. 4.3028 trig second function tan is 76.9 degrees, which is not really all that helpful. So this rotation, 180 minus 76.9, because I didn't make it to 180. And this rotation, 360 minus 76.9, because I didn't make it to 360. And again, I'm going to take my little cheater shortcut. It's not really all that ingenious. 180 minus 76.9 equals that many degrees, which I don't care about, times pi divided by 180 is 1.799, so that's 1.80. This color scheme thing is throwing me off. 1.80 radians. And then finally, final calculation for this note. 360 minus 76.9 equals that many degrees, which I don't care about, times pi divided by 180 equals 4.94. Radians. And we have our answer. If I backtrack through this, you should not always expect 4 answers. It's quite often that you get 4 answers when you're asked 0 to 2 pi, but every once in a while you'll get maybe more, maybe less, depending on the question. So don't make assumptions about the number of answers until never. So that is all for today. This will take a lot of practice, or a little bit of practice, depending on your brain power and your background skills. Brain power, just, are you sleepy? Because I know I'm getting sleepy. So here we go. One more lesson for trig equations, and I'll come back with that later. I'm not pausing this time. I'm going away for a long time.